Have you ever Googled the phrase offshore platform? There is a plenty of them spread in the oceans and seas all over the world. Some of them are fixed, like jacket type, tripod, and monster concrete structures. And some of them are floatings, like semi-submersible and tension leg platforms. The vibration of this platform is not good because it can cause seasickness on manned structure. It means the platform will become uncomfortable for working and living. Additionally, it can prevent the instrument from working properly because most of these instruments require very limited displacement to work and be functional. And moreover, it can endanger the whole structure by causing damage. So what can we do? We can use a stronger member. It means bigger element, thicker element. Is that economical? Of course not. So we have to find some method to control the structural motion. Among the controlling methods, active controls are usually expensive because they require additional data and equipment. For example, I can name the self-positioning or dynamic positioning platform that are using GPS data to limit their displacement. But on the other hand, passive controls can be a good choice. You may be familiar with the suspension system of your car. That's a type of passive control that mitigate the car's motion in the vertical directions. But the one that we are most interested in is the mass dampers. One of the most prominent example and successful projects is Taipei 101, a skyscraper built in Taiwan. Imagine they installed about more than 600 tons of mass at the top level of the building to mitigate the building's motions during the wind and earthquake. We adapted this idea and actually developed our mechanism. That consists of a hollow cylinder that connected to the structure with two springs. We name it hydrodynamic buoyant mass damper. In short, HBMD. Hydrodynamic because the motion of damper can create a wake that contracts with wave force. Buoyant because it's empty and applied upward force and stiffen the structure. And mass damper because it looks like them and additionally have some inherent mass because its motion is in the water. In this regard, our challenge is to find a solution, simultaneous solution of both fluid and structural motion equation. So I sat down and wrote a code, thousands of lines, to model and simulate this phenomenon. As you can see in the graph, the idea of HBMD can reduce the motions of the platform more than 50%. In some point, up to 80%, which is great in civil structures. But is that all? Actually not. We can replace the spring with some type of energy generating devices. And in the same time, we can harvest some wave energy. So simultaneously, we can control the structure and harvest some energy. Thank you.